Hello and welcome back to the Staad Pro class. So in the previous class, we had seen how to work with a beam like this and multiple beams. We had seen two or three of them. And in this particular class, what we'll be doing is we'll be start working with our portal frames. Okay, so if you want me to add some more beams, let me know. I'll try to give you some questions to solve. If you have any issues, you can. I'll add a video on that. Okay, so without any further delay, we'll go and start with the portal frames. So how do we work with portal frames? What is the basic idea behind modeling all these portal frames and everything? So to answer that question, I'll come back here. So in the previous class, what we had done was, let me just zoom in. Okay. So far, whatever beams we have worked with, always we had gone only in one direction. That is, we had gone only in the x direction by giving it values. Okay. Both y and z axes were left at 0 only. So what I mean by that is, if I want to draw, let me just close this. What I mean by that is, if I want to draw something, I always went like 0, enter, okay, and then I give some value 5, enter, and then I give some value 6, enter, or something. This is always taken from this 0 comma 0 comma 0 point. This is basically my, let me take my node cursor on, select this. This is basically my 0 comma 0 comma 0. That's my point of origin. Okay, so all the time what was happening was I was always going on in the x direction. Okay, so to draw the portal frames, I have to go even in the y direction. If I were to come back here and show it to you, so my portal frame, whatever it is, it will come something like this. Okay, randomly something like this it will come. Let me just change the color to something brown. Okay, so it will come something like this, and we will even have some beams running like this from one end to another end, and we'll have some columns running like this from this end to this end. Okay, so in x and y plane is where we get our portal frames. Beams are either only in x direction, either only in z direction. Okay, because if you know how a plan looks, plan has both beams in x and z direction. Okay, in y direction we have columns. So in portal frames, basically what happens, we work basically in x and y direction only. Okay, so how do we approach it? How do we start working with it? So for that, I have got a very simple problem here. It's a basic single story portal frame, and we'll be working with this. Okay, so this point is going to be my 0 comma 0 comma 0. Okay, and then I have to add these points as well. So how do I draw this? So to answer this question, let me do one thing. Let me just select this whole thing. Okay, let me just select this much and bring it over here. Okay, um, just a second. All right, so this is going to be my 0 comma 0 comma 0, and my portal frame is going to start right above this one. So let me just change the line width a little bit so we can see the other line as well. So I have this point, right? This is going to be 0 comma 0 comma 0, and this value by is going to become 4, 0 comma 4 comma 0. So what is going to happen is, let me just take up a black color, or let me take some other color which is not there here. uh, okay, let's go with something like this. The line is too thin, let's make it a bit fat. Okay, okay, that's my axis. Let's go for brown only. And basically what is going to happen is, I'm going to have one line here. Okay, my portal frame basically is going to go up like this, and this point, let me just draw one more line from here so that I don't miss it. This point is going to be what? Is going to be 0 comma 4 comma 0. Okay, so if you have a doubt why is it 0 comma 4 comma 0, I want you to look at this 0 comma 4 comma 0, because y value is what we have to add. Okay, so if I do that much, I'll get this point. Once I have this point, I have to get this point now. So for that, I need to know the distance of x. X is 8. So this particular point will be what? This particular point will be 8 comma 4 comma 0, wherein what 8 is going to be my x-axis. The distance is going to travel from the 0 0.0 comma 0, and then upwards is going to go 4, because y is 4. Once that is done, I have to just take this and I have to just bring it down here like this. All right, and what is this point going to be? This point is going to be simple, uh, 4 comma 8 comma 0 comma 0. Okay, because it is not moving anywhere in x and y direction. Simple one we have got here. Okay, so let me just show it to you. In x direction it is moving 8 meters. Okay, it is not moving in z, it is not moving in y, it is a point which is only on the x-axis. Okay, so something like this we have got here. So if I were to input all these 4 points, I'll get 4 nodes, and then I have to add beams for this 4 nodes. Okay, so I hope you have understood now what we have to input here. So let's start with 0 comma 0 comma 0. Okay, we have already got 0 comma 0 comma 0 over there. Let me just select these two and get rid of them first. Alright, now what I have to do is I have to get the upper point. This upper point I have to get. So for that I have to give y value as 4, and I'll just hit enter. Okay, we cannot see it for now. Let me just do this. Okay, this button will actually display the whole structure for you. Okay, this one, just click on this, it will work. So it will come like this. Okay, so I've got this point and this point. Basically in my drawing, this node and this node I have to get this node next. So I'll give 8 comma 4 comma 0 now. So in the x direction I wanted to move 8, in the y direction I wanted to move 4. I'll give enter. So I'll get that point. Then in the x direction only move 8. I'll hit enter. I'll get this bottom point. Okay. So in matter of 4 steps, I was able to get all the 4 nodes. Now I'm just going to go and add the beam here. All right. Let very quickly we'll just add one beam like this. Okay, so now my almost what I am having is, if I were to see this in x-axis, sorry, front view, it looks something like this. The value is going in x and the value is going in y. Nothing is happening in the z direction. If you see, there is nothing coming. There is nothing coming in the z direction. Okay, now if I were to see this in my 3D view, it looks something like this line diagram. Okay, because we have not added any values to it. So to add values again, all these steps will be repeated multiple times. So we'll click on general. I already have a property defined. If I want to define the property again, uh, let's delete this. Okay, I'll click on define. I'll go to my rectangular property. I'll give some property of zero point 0.4 and I'll give some property of 0.35 or zero point 0.3. Anything works. Okay, for now. Add, close. I'll select this. I'll assign it to view, assign, and click on yes. Okay, generally what happens, columns will have a different dimension, beams will have a different dimension. So if you want to add two separate dimensions and assign them, we can do that also. Okay, so for example, let's take this scenario where in which we have applied something like this and I want to change the property. How do I do that? So I'll just go for define again. Okay, I'll go for rectangle, and what I'm going to do is I'm going to take 0.5 cross 0.5 like this. Okay, these are going to be my columns. I'll add and close them. Now I want to assign the property. So I'll just select this, use cursor to assign and click on assign here and just reassign them like this. It is that simple. Okay. If I will see this in 3D now, it will look something like this. zero point 0.5 cross 0.5 are here. Okay. You can hold your mouse button and it'll move it around. It'll move around like this. Okay. Easily it will move around like this. Alright. So this is basically my beam. These are basically my columns. Okay, so it's that easy to replace it. If I want to replace this one also, I have to just click this, it will replace it. Then hit escape to come out of it. If I want to change again, select the property first, use cursor to assign, click on assign, and select the beam that you want to reassign. Okay, it will change the value for you. All right, so that much is done. Next, I will come for my supports. Now, if you see this diagram, we have got fixed ends here. Okay, so what I have to do, I have to add fixed support over there. So I'll click on create, click on add, select the support, then I'll just come in, use cursor to assign. I have to click on assign first, sorry, assign it and assign it like this. Okay, it is that simple. Next we come for loads and definitions. Again here I'll just click on add. I just want to this you have to create a habit of adding the dead load. Okay, most of the times people just forget to add it. It is very important and crucial. So even if you're doing a practice problem like this, always make it a habit to add dead load. Live load, add and close. Now I'll say this empty case, click on add. Self head is already there in a y direction. Add, close, select this, assign to view and assign like this. Live load, add. Okay, and now comes the problem. Now we have to assign loads now. Okay, so this one we can assign is very easily. This is a simple UDL which we have. So we'll just very quickly assign that. So I'll just come here to my member load, uniform force -20, and as the load is being assigned to the entirety of the beam, I'm not going to give any values here. Okay, I'll just click on add and close this. Now I'm going to select this, use cursor to assign, click on assign and assign it over here. That's simple. Okay, I selected this, use cursor to assign, click on assigning and you can just assign it like this. I'll hit escape now, we'll just come out of it. Okay, so that much is done. Now the problem is I have to assign a load that looks like this. Okay, so far in all the problems that we have done, we have always assigned load where in the negative direction, like this, in the opposite of gravity direction. Okay, every time the loads were going in bottom direction. This is the first time where I'm adding a load that is attached like this to the system. Okay, this is my usual UDL. So this is going to be a usual UDL load which I'm applying like this. Okay, this is going against the gravity direction, so we get GY. But how do I apply this load? Okay, this load is not going in the Y direction, it's going in some other direction. To understand this problem, what we can do is we'll just come here and I want to assign this load. First, let me see what is the load. Load is 30 kilonewton. Okay, so I have got a node here, right? Can I apply a nodal load here over here? Let me just check. I'll click on live load and click on add. Okay, so far we were directly going into a member load and assigning all the member load, but we have something called as nodal load also. Okay, you can use this nodal load and you can apply the load like this. Okay, but in this we don't have directions and all. I'm just discussing the scenarios which we can use or the methods in which we can apply the load. Okay, so what I can do is I'll just go for member load now. Okay, I'll go for concentrated force. Okay, there's nothing like we cannot apply nodal loads. We can definitely apply nodal loads also, but the method which I definitely generally uses, I go for concentrated force here. All right, and I'll see my load. What is the load here? Minus 30. Okay, I'll just add minus 30 like this. Okay, and to just explain what I'll do, I'll just take 4 here. Okay, I think there is the height of the this one section. Okay, 4 meters. All right, so this is what I'm generally initially gonna go with. Okay, I'm just gonna keep it GY because even though I know the load is not going in the Y direction, it is going in X direction. Okay, let me keep it in GY direction only for now. Let's to see how we'll get the loads. Okay, and if we get the correct or not, let's click on add and close. Okay, so we have got our sulfate done. We have got our load done. Now I have to assign this load. So I'll just select this, use cursor to assign, click on assign, and it's assigned over here. Okay, let me hit escape. So where am I getting my load? I'm getting in the Y direction of obviously, because if I just click on edit here, where it is in the Y direction. Okay, so that is wrong. Now how do I change this? To change this, all I have to do is select the load, click on edit. Okay, and it will open up like this for you. You cannot only you cannot just change your load, you can also change your directions. So what I'm going to do, I'm going to make it GX. Okay, why am I making it GX? Because I know this is my X direction, right? Globally I know this is going to be my X direction, so just click on change. Okay, so it is coming in the bottom down part now, and I'm like, no, I want it in the top part. So what I can do is I can just make it 0. Okay, I'm just removing the value that I had given initially, and you can see that load has come like this. Okay, it is that simple to work with this. All right, if you go for supports, we have assigned supports. If you come for loads, we have assigned the loads also. All those are assigned. Now what I have to do is commands, analysis, perform analysis, all. Okay, analyze, run analysis, and save. Okay, we have got some error now. Let's click on done. Staad Pro error message. Density not provided, self-fed command ignored. Okay, let me just come back here. Let's go for property. Okay, we've assigned the property properly. Loads in this one. Let me do one thing. Let me just delete that load directly. Okay, let's try to run this now. That's the issue. Okay. Uh, Materials, concrete, edit. Let me see. Everything is here already. Okay, I have to reassign the values. Just a second. Properties I have to reassign. Let me just delete this and delete this. Okay, let me define them from the start again, from the scratch. Let me just take 0.5 cross 0.5, add, close, select this, assign to view. Yes, I'll come to my support system is done. Loads and definition, I'll just open this up. I'll add this. I'll click on dead case, dead load, add, close, add in the Y direction, close, select, assign to view, assign, yes. All right. So let me just check live loads once more. This is applied. This is also applied. All right. In materials, concrete, edit. All these properties are there. Okay. So let me just analyze an analysis. Save. Okay. Density not provided. Sulfate ignored. Hmm. Okay, so now it is working. I just changed the material from concrete to steel. Sometimes it does that. Okay, so basically the file is corrupted now, and I have to redo the entire system. That's why it keeps asking us to keep saving it every now and then. Okay, so let me just go to post processing mode. Let me just do OK. I'll just come back to modeling again. I'll just come back to general and material property. Go for concrete. Assign to view. Click on assign. Yes, I want to change the property. Analyze, run analysis, and save. I hope it works this time. Okay, so it is working again. Just click on go to processing mode and do it. Done. Just do it. So now we have got the results properly. Okay, so if that issue comes to you, just assign the some other property and then uh, go back and reassign the original property to it, material property I mean. So basically again it gives a deflection value. Hold control and scroll button and you can see this we'll get values like this, I mean a shape like this. I can use it in the front view like this. Okay, so we have some load coming and attacking in this direction, so we can see the entire frame is swaying in that particular direction. Okay, so that is not the thing that we want to check. If you want to click on view values, we can click on view values and you can see node in global X direction, annotate, and you can see how much amount of sway we are getting. Okay, uh, remove all. I want to see beam reactions, so I'll just annotate. It'll ask me that I have to turn it on. Z value, so I'll turn it on. I'll just turn off deflection first, so you can see I'm getting good amount of movements everywhere. Okay, I think I have to. This is wrong. It has to. It is a fixed support. I shouldn't come value as 0. Let me just come here. Let me just check general and supports. Okay, both are fixed supports. Okay, okay, we are getting some value. Let me just go for to post processing and check again. My, I'm sorry, MZ. Let me just hold the control and make it bigger. Okay, we are getting some value here. Sorry. Okay, very small amount of value we're getting, but it is not 0. We're getting some value. All right, and moreover, I have given very thick amount of this one. I think I have not used the sections that are provided in this particular workbook. So results, view value, beam results, maximum, midpoints, and ends. Annotate them, and you'll see the values here. Then I want to check. I'll just do remove all. Turn this off. I'll go for FO5. Maximum and annotate them. I'll get values like this. And if I want to see reaction forces, let me just remove all first. Reaction forces, I want to see global X and global Y direction or even global Z. I can annotate them and you can see they are here base reaction forces I'm getting. Okay, if you want to see bending values also, you can check the bending values by annotating them like this. All right, so this is how you work with a simple single story portal frame, and in the next class I'll show you how to work with a bigger frame. Okay, this will have 2 stories in that. Let me just quickly come down here. Okay, we'll be working with this kind of a this one, and I'll show you how to add moment forces and everything into your building structure. Okay, so see you guys in the next class. Thank you.